Good morning, Tier 4. I hope you're all doing great, guys. So today we're going to continue answering the practice worksheet in your resource pack. This is the second and the last part of answering the practice worksheet. And then starting the next session, which is going to be our live session on Wednesday, we are going to answer together the final practice worksheet that I have prepared for you. It's going to be uploaded tomorrow, inshallah, with its model answer so that you can take a quick look on them before we start answering it together on Wednesday. So let's start together with our practice worksheet. So first, I'm going to answer the homework that I gave to you on Wednesday. It was the reading homework, page 92, which was related to the magnetism lesson. Use the textbook to help you fill in the blanks. What is a magnet? A magnet is an object or a material that attract things containing dash nickel or cobalt. So iron, IC nickel, iron, nickel, and cobalt. Number two, magnets can attract, and what do they do when two alike poles face each other? They repel, so they can attract or repel each other. Number three, all magnets have a north pole and a or an south pole. Number four, the north poles and south poles of two magnets will, if they are facing each other, the north poles and the south poles of two magnets, they are going to attract to each other. Number five, magnetic force dash when magnets are close together. So the answer is appear, or you can say strengthen when they are close to each other, and they disappear or weakens when magnets move farther apart. The next question is, what are magnetic fields? It says a magnetic field is the region of magnetic what around a magnet. It is a region of magnetic force around a magnet. What is an electromagnet? An electromagnet is a magnet produced by a or an electric current moving through a wire that can be turned off with a or an with a switch. Number eight, the amount of current determines the strength of a magnetic field, of course. The more the electric current, the more the strength of the magnetic field. Number nine, industrial use of magnets are electric motors and electric generators, and you will find it in the extend of your closer lookbook, or you can write cranes that pull up metal scrappers, whatever you or we have talked about the industrial use of magnets, you can add in those two gaps. Number 10, it says types of magnets are, of course, we've learned about several types and shapes of magnets. We have the bar magnet, we have the horseshoe, we have the disc magnet, the rod magnet, and the wand magnet. Now let's start with completing your final practice worksheet. This is question number 3. It says, David put two bars of iron close to each other. There was no magnetic force between them. David recorded the results as shown below. So they mentioned that there was no any magnetic force between them. So two iron bars, they are not magnetic. So he recorded that there is no magnetic force. We're going to help David do the rest of the recordings. David did 3 other tests. Tick the correct box to show the result for each test. So here he approached a bar of copper to a bar of magnet. Copper, if you remember, we said that there are certain magnetic materials of the metals, which are IC nickel and steel, iron, cobalt, nickel, and steel. Copper is not one of them. because some of you still get confused between copper and cobalt. It's cobalt, not copper. The magnetic metal is the cobalt, not the copper. So in this case, nothing will happen also between those two, so no magnetic force. Some of you will be confused and they will tell me it's going to repel. No, it's not going to repel, because this, if they repel, this means that this bar is a magnet too, and the two similar sides are facing each other. But as long as this part is not magnetic at all, it's not going to make any reaction against the magnet. Okay, the next question is, we have a bar of iron and a bar of magnet. Yes, in this case we said that iron is one of the magnetic metals, so it means that it's going to attract. The next is bar of steel and against the bar of magnet. Again, this is of course going to attract. Question number 4 says, the two magnets below are attached to each other. On each magnet, label N for north and S for south. One has been done for you. So this is the north part, and they said here that they are attached to each other. So this means that they are going to be attracted to each other. So this means that this is going to be north. This means that this is going to be south, and this is going to be north, and the other is going to be south. Okay. Next is, a magnet has been broken and the two pieces are shown in the diagram below. Complete the diagram. Now, this is a tricky question. I want you to pay extra attention to this part, please. A magnet, a single magnet like this one, not those two, this one only, when it gets broken, the broken pieces turn into a magnet itself. It's going to be acting like a separate magnet. So this means that when this bar, it was one piece, when it got broken, this is going to be the south pole and this is going to be the north pole. Each part of the broken parts is going to act like a single magnet. So again, this was a bar of magnet, a single bar. They were attached to each other. They were like a one-piece bar magnet. This is the north pole of it, and this is the south pole of it. It got broken. When it gets broken, each part of them will act like a separate magnet, like it has its own magnetic properties. So if this is the north pole, this is going to be the south pole, and if this is the south pole, this is going to be the north pole of the magnet. Now, C says, what is the name given to materials that are attracted towards a magnet? Of course, we know it's called the magnetic materials. Question number 5 says, complete the following sentences. The ends of a magnet are called, of course, we know that they are called the south pole and the north pole. Next, what metal are magnets made from? We know that they are made of several types of magnet. They could be made of several types of metals, which are, let's remember, nickel, and steel. Iron, cobalt, nickel, and steel. When magnets repel, do they get attracted to each other, or they move away from each other? Yes, you were right. They move away from each other. B, circle, true or false? So the first one says non-metals are magnetic. No, this is a false, because all of the iron, cobalt, nickel, and steel, all of them are metals, and they are only the magnetic materials that we know about. The second question says all metals are magnetic. Again, this is a false statement, because only those 4 of all of the metals are the magnetic metals. Question 6 says, Theo is at a recycling center. He sees 5 containers with contents that need separating. So he has here like 5 piles of stuff that need to be separated in order to recycle them. And the question is, pick 3 containers with contents that can be separated with a magnet. So some of those piles have magnetic materials that could be separated from the other material using, of course, a magnet. So let's start with the first one, aluminum cans and paper. Now, aluminum cans are metals, but it's not a magnetic metal. So it's not going to be affected by the magnet. So this is definitely not going to be one of the piles that will be separated using a magnet. The next is steel cans and plastic bottles. We know that steel is a magnetic material. So this means that the magnet is going to affect it for sure. The next is glass jars and steel leads. So again, there is steel, and as long as there is steel, this means that it's going to be attracted to the magnet and separated from the glass jars. Next is plastic bottles and paper. There are no metals here, so definitely they are not magnetic. The next one, iron nails and copper nails. We know that the iron is magnetic, but the copper is not magnetic, so the magnet will be perfect for separating this mixture. So this one too is going to be separated using a magnet. The next page and the last one is page 102, has starting question number 7. Some metals are attracted to magnets. In the list, tick the magnetic materials. We have the lead. It's a metal, but it's not a magnetic metal or a magnetic material. There is the copper. It's a metal, but not magnetic. Iron, yes, iron is metal and magnetic. Magnesium, it is a metal, but not magnetic. Steel, by the way, is not a specific type of metal. Steel is a type of iron, so that you won't get confused. Steel is a type of iron, so it also has its magnetic properties. So steel is one of the materials. And last is the nickel, and we all know that the nickel is one of the magnetic materials. Question B says, Peter places a sheet of glass over 2 magnets. So he has 2 magnets and he puts a sheet of glass over it. The diagram shows that what happens when he shakes some iron filings over it. So when he adds some iron filings over it, in this case, this what happened. Some iron filings got attracted to this bar, and some other pile of filings got attracted to the other bar, but both of them did not get attracted to each other. The question is, what does this tell you about the poles of the magnet? So they are not attracted to each other, and the magnets also are not attracted to each other. This means that they are repelling from each other, and this means that the similar poles are facing each other. The 2 poles facing each other are the same, so they are repelling from each other. The next one, Peter moves one of the magnets. So most probably he flipped one of the magnets. The diagram shows his new results. When he flipped one of the magnets, this happened. The iron filings got attracted to both of them, like they are doing a wave between the 2 bars. What does that tell you about the poles of the magnets? It's very obvious that they are the poles facing each other are different, so this will make them get attracted to each other. For those who did not understand this, I have this picture that will show you the difference. The upper one, as you can see, this is the South Pole and this is the North Pole. The iron filings are making like waves between the 2 of them, and they are like at getting it like they are connecting the 2 magnets to each other, because they are the different poles are facing each other. But as you can see, in case that the similar poles are facing each other, the iron filings that are surrounding them, they themselves acting like magnets with similar poles facing each other. So they are trying to push each other away, and they are repelling from each other, as you can see. I think now it's obvious for you guys. So this is it for today, guys. I hope you find it easy, and I think it's very easy. So as I told you, I'm going to be uploading your final practice worksheet and its model answer tomorrow on Google Classroom. You can check it out and be prepared for our live session. We're going to start answering it together and revising all of the previous lessons that are going to be included in your exam, including things that we have learned in the second trimester resource pack. I'm going to tell you everything about it in our live session. Until then, I hope you're all doing great. See you soon, inshallah, and bye bye.